All right, guys, our last review lesson in the prerequisite chapter is solving systems of equations. I have a reminder for you that a system of equations is, for us, two equations with two variables, and we solve for both variables. In later levels of math, there will be more than two variables. So a generic version would be a system of equations with many variables, and we solve for all variables. But for us, it's just two. There are three ways that you have learned to solve systems, and I'm going to review each one of them with you and tell you which I prefer and which I think will be easiest for you. The first method is elimination, and with elimination, you're trying to do what its name says. You're trying to eliminate one of the variables so that you can solve for the other one and then plug back in. In order to do elimination, you need one of your variables to have like coefficients, the number out front, with opposite signs. And sometimes you have to do work for that. In an Algebra 2 trig, you'll always have to do work for that. So, for example, I have 3x plus 5y equals 18, and 6x minus 8y equals negative 18. My variables on my x are 3 and 6. My coefficients on my x's are 3 and 6. My coefficients on my y's are 5 and negative 8. None of them are set up pretty, so I'm going to have to do some work. If I want the x's to eliminate, I could make the top one negative 6 and leave the bottom one alone. If I want my y's to eliminate, they're opposite signs already, but I would need to find like coefficients. So in this case, it would be 40. So I'd have to multiply the top equation by 8 and the bottom equation by 5. It does not matter what you choose to do. I choose to do the least amount of work possible. So I'm going to eliminate my x's because I already have a 6 in the bottom, and if I multiply my entire top equation by negative 2, then my x's will be eliminated. So I'm going to do that. Distribute that through, and copy your bottom one down. And now when I add those equations together, the x's are eliminated. Again, that's why we call it elimination. Combine like terms and solve. Y is 3. Well, I'm not done because it's a system. I need to also find my x value. So you take that y equals 3 and you substitute it into either equation. I'm just going to pick the top one. Again, in Algebra 2 trig, you can use your calculator. So you might not show all this work. Mine's just not handy. So I think that x is 1 when y is 3. I write that as an ordered pair every time I see x and y to remind myself that they're points, x, y. These are actually two lines intersecting at the point 1, 3. You should always go back in and check into your other equation using your Inspire like I showed you the other day. So store 1 for x, store 3 for y, plug in to this equation, type that equation, and it should come up true. I'm not going to take the time to do that for the video. Elimination is the method that I rarely use. I prefer substitution if I'm asked to solve algebraically, so we'll do that next. Our second method is substitution, and it is also just like it seems. Here I have 6x minus 3y equals negative 9, and y equals 7x minus 2. Because I have y alone, I can take that value for y, 7x minus 2, and substitute it into the other equation's y. So let's do that. 6x minus 3 times y. Well, y is 7x minus 2 equals negative 9. Solve that equation. So here we get x equals 1. Just like in the last problem, that's only part of the answer. This is a system. I need both variables. So I take that x value and I substitute it into one of the equations. I always go for the simpler one, y equals, in this case. And I get y equals 5. Again, because I have an x and a y, I write that answer as an ordered pair. Again, I take the time to substitute x for 1 and 5 for y into my other equation and check. At this point, the last method for solving a system is by graphing. So here I have y equals negative 5 halves x plus 2. That's a line. And I'm going to be not really neat about it for notes. Yes, you should use rulers for your axes and things, but this is a quick review. Y equals 5x plus 2 has a y-intercept of 2. I plot that first. A slope of negative 5 halves, so I can go up 5 to the left 2, or down 5 to the right 2. Grab a ruler and connect. Now, because this is a system, you're going to need to label each equation. Like I did there. Okay. Now we graph the other equation. Well, this is a line also because there's nothing squared, but I need to get y alone. So first, I will subtract 4 and then divide everything by 2. So I'll end up graphing y equals negative 1/2 x minus 2. I have a y-intercept of negative 2 and a slope of negative 1/2 x. So I'm going to go up 1, left 2 to force that negative slope. Oops. Or down 1, right 2. You get enough points to determine your line. Connect them. Label with your original equation. And the solution to this system is the point of intersection, which in this case is 2, negative 3. Circle it, label it, and then of course use your Inspire to check. Plug in, replace 2 with x and y with negative 3. Plug into both of your equations, make sure you get trues. In class, we'll talk about using your Inspire to graph and find the point of intersection. That's it. Have a great night.